Okay, this is just kind of to go over what we had done on the Friday before Thanksgiving. 8.0 determinants and multiplicative inverses. So I'm gonna remind you of those things, show you them, and if you weren't here at all, then I guess I'm gonna teach it to you. And then we're gonna do a couple practice problems, and I'm gonna show you how to do it in the calculator as well. Actually, I'm gonna show you two methods in the calculator. The second one I show you is something that we might learn by hand, we might not. It might be something that you just learn in college if you go further in mathematics. Okay, depends on how much time we have. So, as far as matrices go, there are a couple different things that we need to know. The determinant of a matrix A, B, C, D is A times D minus B times C. So the determinant is this expression. So if you were not here on Friday, then you need to pause and write that down. Determinant sometimes shows up on the ACT and it just looks like find the determinant, or it might say that, in which case you can just find that by multiplying this times this minus that times that. I believe you can also find it in the calculator. Let's see. Yeah. I'll go ahead and show that to you. Okay. So you might notice right here above this x to the negative 1 it says matrix in blue. So we're going to go second matrix. I'm going to, well, actually, just kidding. I'm going to do that in the home screen. Okay. So I'm going to go to second matrix, and I'm going to go over to math, and you see that the first thing is DET, determinant. Now what I was about to show you was how you can enter a matrix into the matrix editor and then just type in the variable, but I think we're just going to use the alpha zoom right here. So if you press alpha zoom, you actually end up with this row column type thing, right? So we're going to do the determinant of a 2 by 2. And let's do the determinant of this one right here since it's right there. So when you type in a matrix, all you have to do is type in the numbers and keep pressing to the right until you're done. So 8, right, negative 5, go to the right, and it pops on here. 2, go to the right, 1, and then we're finding the determinant of that, and you get 18. And that's what it is. So if you are finding it by hand, you can do that, but if you're on the ACT and you remember, then you can just do determinant of the matrix. And that's all under matrix and alpha zoom. Okay, but the important part is knowing AD minus B times C. Okay, then we have the adjugate. So the adjugate of a matrix is just where you switch A and D and you change the sign of B and C. So this right here, for 8, negative 5, 2, 1, we switch 8 and 1, so 1 and 8. 2 becomes negative, and negative 5 becomes positive 5. Okay, so this is the adjugate. These are two different things that are necessary to find the multiplicative inverse. So the multiplicative inverse is found by saying 1 over the determinant times the adjugate of the matrix. Okay, so write down multiplicative inverse if you weren't here on Friday, and then write down this expression. So we found that the determinant of this was 18. So 1 over 18 times the adjugate, switch the 8 and the 1, change the sign of 5 and negative 5 and 2, and then distribute the 1/18, so scalar multiplication. So that becomes 1/18, 5/18, negative 2/18, which is negative 1/9, and 8/18, which is 4/9. So then what I wanted to prove to you was that, multiplicative inverse is the same thing as saying, like, if I tried to solve this equation, then the multiplicative inverse is what I can multiply this side by to get just x, and that's multiplying by 1/4. And so that's the idea, is to simplify it down to 1. Well, the equivalent of 1 in this matrix is the row reduced echelon form 1, 0, 0, 1. So if we were to multiply the multiplicative inverse, this whole matrix, times the original matrix, row by column, row by column, row by column, row by column, then you end up seeing that you get the row reduced echelon form. And I'll show you how that works out in just a second. To solve an equation, I mean. This is going to be the idea of what we're doing. We're trying to solve for. Although multiplication is very, with matrices, order is important, and so it will matter whether or not, if I multiply on this side, then I have to, in fact, multiply right there. And we'll see. So, okay, 2x plus 4y equals 22, and negative 3x plus 2y equals 7. So the first thing I want to do is I want to find the determinant So the determinant, we'll let this be matrix. Oh, just kidding. I gotta let it be in matrix A. So I'm going to rewrite this as a matrix equation. So 2, 4, negative 3, 2 times xy equals 22, 7. I don't know why I put that. I was tempting to write a fraction bar. Okay, so 22, 7. All right, and the idea is that if I were to multiply this out, I would get back to this. So row by column, so 2 times x plus 4 times y. Row by column, negative 3 times x plus 2 times y. And then equals these two. Okay, so the determinant of, let's let this be matrix A, will be 2 times 2 minus 4 times negative 3. So I've got 4 plus 12, which is 16. So the determinant is 16. Now let's find the adjugate. The adjugate is where we switch the x and, or not the x and the y, the a and the d, and those are in fact the same, so it doesn't matter. We change the sign of this, we change the sign of that, and then the multiplicative inverse is where we multiply. Ooh, I just grabbed everything. 1 over the determinant, so 1/16 times the adjugate, which is 2, negative 4, 32. And if you multiply that out, you distribute your 1/16, you get 1/8, negative 1/4, 3/16, and 3/16. Why do I have a 3 right there? It's a 2. So that should be 1/8. Okay. So the idea is the same as what we do with that simple equation that I had just a second ago. If I have 3x equals 1 and I'm trying to solve, then I multiply both sides by the multiplicative inverse 1/3, because that simplifies this side down to just x equals 1/3 times 1, which is 1/3. So what we're going to do is we're going to multiply this by this matrix right here, and it should simplify down to the essence of 1 in a matrix, which is 1, 0, 0, 1. I'll show you how that works. So I'm going to multiply this out front. So 1/8, just to make sure. Okay, 1/8, negative 1/4, 3/16, and 1/8 times 2, 4, negative 3, 2 times xy. Oh, equals, now multiplication is very important, so I have to put the multiplicative inverse first again. Negative 1/4, 3/16, and 1/8 times 22 sevenths, or 22, not sevenths, 22 sevenths. Okay, now I'm going to multiply this out just to show you that it works, but in actuality, your goal is to go from here to here, which is the answer, okay, because this is supposed to simplify down to 1. You don't have to multiply this out, you just multiply this out. Now, if you multiply this out and you get some really weird answers, then maybe something is wrong. Okay, so we multiply by row by column. Row by column. This is a 2 by 2 by a 2 by 2, so the answer is going to be a 2 by 2. Okay, so the first one, row by column, 1/8 times 2 is 1/4, and then negative 1/4 times negative 3 is positive 3/4. So row, this times this, plus this times this, and that is 1. Okay, row by column, so first row, second column, 1/8 times 4 is 1/2, and then negative 1/4 times 2 is a negative 1/2, and that adds up to 0. Row by column, 3/16 times 2 is 6/16, which is 3/8. And then 1/8 times negative 3 is negative 3/8, and that adds up to 0. That was row by column, and then row by column. So 3/16 times 4 is 12/16, which is 3/4. And then 1/8 times 2 simplifies down to 1/4. So 3/4 plus 1/4 is 1. So you see how we end up with this times this gives me 1001 times xy. So that is, if I were to multiply row by column, I would end up with 1x plus 0y. And then I would end up with 0x plus 1y, which is the same thing as just saying, these are just, so this is a 2 by 2 by a 2 by 1, so my answer was a 2 by 1. 2 rows, 1 column. This is an x and a y. Yeah? So it simplifies down to just back to xy, which is why this can just go away. Similarly, how this 1 can go away because you don't need it. So the real answer is over here, multiplying these two out. Row by column. So again, I've got a 2 by 2 times a 2 by 1, which simplifies down into 2 by 1. So 2 rows, 1 column. Okay. 1/8 times 22 is 11/4 plus negative 1/4 times 7 is a negative 7/4. That adds up to a 4/4, which is 1. And then this one right here, we've got row times column. 3/16 times 22 is going to be 33/8. And then 1/8 times 7, and I got that from saying, just to be clear, 3/16 times 22, I divided them both by 2 and got 11/8, and so 33/8. 1/8 times 7 is 7/8, and so that ends up being 40/8, and 40 divided by 8 is 5. So the answer is the coordinate point 1, 5. X is 1, y is 5. And so there's the solution. Now, let me show you a couple ways to do that in the calculator. Okay, so if I were to take this equation right here. So first off, I could do all of this inverse stuff in the calculator, and I'm okay with you showing that just to see that you get the right answer. So what I'm going to do is I'm going to do alpha zoom. I'm going to do the matrix. I'm going to do a 2 by 2 just for this one, this piece. And we've got 2, 4, negative 3, and 2. And then what I'm going to do is I'm going to use this right here. And this finds the inverse of it. Okay? So this right here is the inverse, the multiplicative inverse of that right there, which is what we found, right? So I'm going to multiply that by this matrix right here, 22, 7. So alpha zoom, this is a 2 by 1, 2 rows, 1 column. 22, 7. Press enter, and you get the final answer, which is 1, 5. Okay? All right. So that's using multiplicative inverse and doing all of that in the calculator. There's another way you could define the matrix in here. So I'm going to go second matrix and show you that real quick. I'm going to go to edit, and I'm going to enter in this one right here. So you got to make sure your dimensions are right. So 2, enter, 4, enter, negative 3, enter, 2, enter. Okay, so I've defined matrix A as a 2 by 2, that's this. So another thing you can do is you can actually just go to matrix and then A. So matrix A and then the inverse times, and then you could say the 2 by 1, 22, 7. Or you can do define another matrix as 22, 7, and there you go. Okay? Now I do want to show you one more method. So, and since I talked about it, I'll go ahead and do it. Row reduced echelon form is 1, 0, 0, 1, and then with the augmented matrix where you've got like the answer 1, 5, yeah? So if you can make the augmented matrix, which is the original, 2, 4, negative 3, 2, 22, 7. If you can make that into this right here, then you've got your answer. And actually, you can do that right in here. I might show you how to do that by hand later, but right now I'm just going to show it to you. So this is another way to solve using matrices in the calculator. So I'm going to go to second matrix. I'm going to go over to math, and up or down, doesn't really matter, but up is faster. Row reduced echelon form. Okay, so I'm going to do that, and then I'm going to do alpha zoom. This is a 2 by 3, 2 rows, 3 columns. Press OK, and then 2, 4, 22. Keep pressing to the right. Negative 3, 2, 7. Press enter, and you see how you get 1, 0, 0, 1. And they don't put the bar there, but that's what that means when you're dealing with an equation. So this stands for x, and this is y. So 1x plus 0y equals 1. So x equals 1. 0x plus 1y equals 5. So you get x equals 1 and y equals 5. Okay? Well, hopefully you can go through that process if you need to go through the video again, if you need to remember any of those processes. But I'm going to give you some homework, and you're going to be able to, I want you to do it by hand and practice the multiplicative inverse, practice finding your adjugate and your determinant, but then you can also use your calculator, okay, to check your work.